Across history, farming has demanded innovation, and the answers have come in many forms. But during certain eras, one approach stood above the rest: scale. By building machines larger than anything seen before, engineers gave farmers the strength to work wider fields, pull heavier implements, and accomplish in hours what once took days. These are the 10 largest agriculture machines ever built. Machines so immense that they seemed almost out of place in a field. Number 10. Claas Lexion 8900 TerraTrack. When Claas introduced the Lexion series in the 1990s, it marked a turning point in modern harvesting. The Claas Lexion 8900 TerraTrack later emerged as the flagship, representing both a technical achievement and a statement of scale. Built for the world's largest farms, it was created to cover hundreds of acres in record time, standing among the largest combines ever produced. The physical presence of this machine left a strong impression. With its tracked undercarriage, the TerraTrack looked more like an industrial crawler than a traditional combine. Measuring well over 30 feet in length and more than 14 feet in width, it dominated fields visually as well as mechanically. Its grain tank offered capacity above 18,000 liters, which meant harvesting could continue for long stretches without frequent unloading. For farmers working tight harvest windows, this advantage was crucial. Beneath the hood sat a 12-cylinder Mercedes-Benz diesel engine. Displacement measured 16.2 liters, which equaled 988 cubic inches. This immense block provided the durability and strength needed to power the combine steadily during long shifts. By installing an engine of such scale, Claas ensured that the TerraTrack would not falter when conditions turned demanding. The horsepower rating reinforced its scale, producing nearly 790 horsepower. That figure placed it at the very top of its category, far above most other harvesters on the market. Yet numbers alone did not tell the whole story. The advanced driveline distributed power evenly, giving operators smooth control in crops of varying density. It was this mixture of strength and refinement that made the Lexion 8900 TerraTrack so effective in practice. Torque added to that reputation. The V12 generated more than 2,900 pound-feet, a figure more often associated with industrial machinery. This allowed the harvester to continue pulling through heavy crop stands without hesitation, even when loaded close to capacity. That immense torque transformed potential strain into steady productivity. Road travel speed also set the machine apart, capable of reaching nearly 25 miles per hour. It moved between fields more quickly than earlier combines of similar size. For operations spanning wide acreages, this saved valuable time. Fuel use was substantial, as expected from such a large harvester, but efficiency per ton harvested remained competitive. Farmers measured its value not only by output, but also by cost per acre. And here the Claas held its own. What made the Lexion 8900 TerraTrack notable was how its features complemented one another. The massive grain tank, wide headers, tracked base, and Mercedes-Benz power plant were not separate highlights, but parts of a unified system. Together, they created a combine that defined industrial-scale farming in the 21st century. As agriculture expanded toward ever larger fields, the TerraTrack was ready to meet the challenge. It remains a striking symbol of how harvesting machinery has grown in size and performance. Number 9. DB12048 Row 30 Planter. When John Deere unveiled the DB12048 Row 30 planters in 2009, it instantly redefined what farmers thought was possible in a single pass. Planters had been growing larger for decades, but nothing matched the scale of this machine. It was not simply another tool for seeding. It was a turning point in the mechanization of large-scale agriculture. Built to meet the needs of farmers in the American Midwest, where field sizes stretched for miles, the DB120 stood as the largest production planter in the world at the time of its release. The first thing that set this planter apart was its size. Unfolded, the toolbar spanned 120 feet, which was wider than many roadways and longer than a Boeing 737 wing. This extraordinary width allowed the machine to cover nearly 3 acres with every pass, making it a symbol of efficiency in regions where timing was critical. With 48 rows, spaced 30 inches apart, the DB120 made quick work of planting corn on vast operations where a smaller planter would take days. Although it lacked an engine of its own, the planter relied on massive tractors to operate effectively. farmers typically paired it with machines rated at 370 horsepower or higher, since the hydraulics, folding mechanisms, and seed delivery systems demanded substantial energy. That requirement underlined the scale of the DB120, since only the most powerful tractors could truly unlock its potential. In many ways, it symbolized the partnership between giant tractors and equally enormous implements that defined modern agriculture. The technical sophistication matched the physical size. Precision planting technology ensured that every seed was placed at uniform depth and spacing, a task that required more than brute force. Hydraulic drives and electronic controls allowed operators to monitor and adjust in real time. These systems turned the DB120 into a planter that was huge, but also remarkably accurate, giving it both quantity and quality in one package. Transporting the machine was its own story. Folded for the road, the planter still stretched to an imposing footprint, requiring careful maneuvering on rural routes. Even in transport mode, its weight exceeded 32,000 pounds, making it one of the heaviest pieces of seeding equipment ever seen on farms. Farmers planning to run the DB120 often had to consider not only the fields, but also the logistics of moving such a structure from one location to another. The planter's reputation grew quickly. Operators praised how it cut down on planting days, especially during narrow seasonal windows when weather could close in. By finishing jobs faster, the DB120 reduced risk and improved crop emergence. Efficiency at this scale translated directly into profits, since planting speed often meant the difference between average yields and record harvests. It earned its reputation by showing how large-scale farming demanded equally large tools. More than the longest production planter of its time, it represented the shift toward operations that measured efficiency in acres per hour, rather than acres per day. In the story of the largest agricultural machines ever built, the DB120/48 row 30 planter holds a unique place. It was not about horsepower or torque, but about sheer reach and precision. A machine that transformed planting into an act of industrial-scale farming. Number 8, Big Bud 16 V747 four-wheel drive tractor. In the late 1970s, as farms in the American West expanded to unprecedented sizes, a group of builders in Havre, Montana, set out to create something the world had never seen before. Their answer was the Big Bud 16V 747 four-wheel drive tractor, a machine so immense that it dwarfed nearly everything else in its category. Built in 1977 for a cotton grower in California, it was designed not simply as another large tractor, but as a purpose-built solution for farming on a scale that demanded strength and endurance far beyond ordinary machines. From the start, its physical size set it apart, standing more than 14 feet tall and stretching over 27 feet in length. The Big Bud 16V 747 looked more like a piece of heavy construction equipment than a farm tractor. Its massive frame supported some of the largest agricultural tires ever fitted, each measuring more than 8 feet in height. This colossal stance was not for appearance alone. It provided the stability needed to handle some of the widest implements in commercial farming. Farmers who saw it in person often remarked that it seemed almost impossible that a tractor of such magnitude could work the land. Power for this machine came from a Detroit diesel 16-cylinder engine. The displacement measured 27.02 liters, which equaled 1,690 cubic inches. With this foundation, the Big Bud had reserves of strength unlike any tractor that came before it. The engine was originally rated for 760 horsepower, though later adjustments pushed the figure even higher. That level of power was extraordinary in the late 1970s, setting a benchmark that few machines could approach for decades afterward. Torque figures were equally staggering. The Detroit diesel delivered more than 2,500 pound-feet, enough to pull the heaviest tillage equipment across wide expanses of soil without hesitation. At a time when most tractors struggled with fewer than half that figure, the Big Bud established itself as a force of mechanical endurance. With torque at this level, the tractor could operate tirelessly through the densest soils, making it a trusted partner for some of the largest farms in North America. Travel speeds were modest but practical, with road movement topping out at just over 10 miles per hour. While it could never match smaller tractors in pace, speed was not the point. The Big Bud was built for continuous heavy draft work, where raw power and staying ability mattered more than transport efficiency. Fuel consumption was naturally high, yet when measured against acres covered per hour, the tractor offered impressive economy for its scale. It was the type of machine that converted massive inputs into equally massive outputs, which is why it remained in service for so many years. Only one example of the Big Bud 16V 747 was ever constructed, and its reputation was built on performance rather than production numbers. Farmers recognized it as a machine capable of handling implements and workloads that smaller tractors could not manage. Even decades later, it remains notable for its unmatched size, its massive output, and its continuing presence as a working example of engineering, built to meet the demands of very large farms. And that's just the beginning. The upcoming machines will push the limits of size and performance even further. Show your support with a like and subscribe to join us as we uncover the rest of this incredible list. Number 7. Ropa Tiger 6S Beet Harvester Machine. By the time the Ropa Tiger 6S appeared in the 21st century, sugar beet harvesting had already gone through decades of mechanization. Earlier machines were smaller and less efficient, often requiring multiple passes or constant unloading, but Ropa set out to design a single harvester that could handle the largest fields with minimal downtime. The Tiger 6S was built in Germany with the intent of providing unmatched output for farms across Europe and North America, where sugar beet cultivation demanded heavy-duty equipment that could stay in the field for long hours. Its overall design reflected that purpose. The Tiger 6S stood on a 3-axle frame, giving it stability even when carrying a full load of beets across uneven terrain. At more than 50 feet in total length and weighing over 60 tons when loaded, it towered above conventional harvesters. The bunker capacity was especially significant, offering more than 35 cubic yards, equal to roughly 64,000 pounds of harvested beets before needing to unload. This capacity meant operators could spend more time collecting and less time stopping, which dramatically improved efficiency. To move such weight reliably, Ropa fitted the Tiger 6S with a 12-cylinder diesel built by Mercedes-Benz. The displacement measured 15.6 liters, equal to 950 cubic inches. This engine was engineered for endurance, ensuring steady operation under the heavy strain of lifting, cleaning, and transporting beets during long harvest days. By focusing on durability, Ropa gave the harvester the ability to function consistently, even in demanding soil conditions. Horsepower output for the Tiger 6S reached approximately 790 horsepower, a figure that positioned it among the most powerful self-propelled harvesters ever placed in fields. Such strength allowed the harvester to power its lifting units, cleaning systems, and large bunker simultaneously without loss of performance. In practice, this meant farmers could trust the machine to maintain productivity hour after hour, even when working through wet soil or compacted ground. Torque delivery matched the horsepower rating, with the engine producing more than 2,900 pound-feet. This torque ensured smooth forward motion while lifting heavy loads of beets from the ground. Unlike smaller machines that might strain or lose speed under full capacity, the Tiger 6S kept moving steadily, which was essential for farms operating under narrow seasonal harvest windows. Transport speed on the road was another area where the harvester stood out. Capable of reaching close to 25 miles per hour, it could travel efficiently between fields spread across large acreages. While fuel consumption was high due to its size, efficiency was measured not in gallons per hour, but in tons harvested per day, and here the Tiger 6S consistently delivered strong results. Every detail of the Tiger 6S was designed with scale in mind. Its lifting system covered a wide working width, its cleaning units handled heavy soil with precision, and its spacious cab provided operators with advanced controls and clear visibility. Rather than excelling in a single area, the machine brought together capacity, power, and control into a complete harvesting system. The Ropa Tiger 6S became a benchmark for sugar beet harvesters because it balanced scale with practicality. Farms adopting it were able to complete harvests more quickly and with fewer machines, proving that one large harvester could outperform several smaller units. Number 6. New Holland CR10.90 tracks HSCR. When New Holland launched the CR series in the early 2000s, the company aimed to redefine what combine harvesters could achieve on large modern farms. Out of this line came the CR10.90 tracks HSCR, a version that built upon record-setting performance with improved stability and ground contact. Farmers dealing with heavy soils or wet conditions needed a machine that could not only process enormous volumes of grain, but also travel where wheeled combines struggled. The addition of the track system made this variant a dependable choice for farms that demanded consistent output under challenging circumstances. The design of the CR10.90 was centered on efficiency and throughput. At its core, the combine used twin-rotor technology, a system pioneered by New Holland to handle grain with reduced losses and cleaner separation. This allowed operators to harvest more acres per day without compromising crop quality. The Trax HSCR model carried these advantages into even tougher field conditions by replacing conventional wheels with a track undercarriage. Trax distributed the machine's massive weight across a broader footprint, lowering ground pressure and preventing deep soil ruts. For large farms, this meant harvesting could continue, even when rains had softened the fields, where ordinary machines might be forced to wait. At the heart of the CR10.90 was a Cursor 16 diesel engine. Displacement measured 15.9 liters, equal to 971 cubic inches. This engine was chosen for its reliability under high loads, ensuring that long harvest days could be completed without mechanical compromise. New Holland's engineers designed the system not only for strength, but also for smooth power delivery, which meant operators could maintain steady performance even when crop density varied across fields. Horsepower ratings confirmed its scale, reaching more than 670 horsepower. That figure gave the combine the muscle to operate its wide headers and maintain capacity when harvesting crops such as corn, soybeans, or wheat at peak yield. Farmers found that the power translated into reduced bottlenecks during harvest, keeping grain moving steadily through the rotors and into the massive tank without interruptions. Torque was another factor that made the CR10.90 effective. The engine produced close to 2,800 pound-feet, giving it the reserve needed to keep pulling material through when conditions grew tough. Instead of slowing down or losing efficiency, the combine powered ahead, which kept output levels consistent during the most critical days of the season. The grain tank itself had capacity beyond 14,000 liters. Combined with unloading rates designed to empty the tank quickly, this allowed operators to spend more time harvesting and less time stationary. The unloading auger was engineered for both speed and reliability, ensuring that even at full loads, the process of transferring grain into trailers was smooth and efficient. On the road, the CR10.90 could move at speeds approaching 16 miles per hour, a practical figure for transporting between large fields. For farms spread across wide areas, this mobility was a valuable feature. While fuel use was significant, the combined balanced consumption with productivity, delivering cost-effectiveness through sheer scale of harvested grain per hour. The CR10.90 Trax HSCR was a solution for farms where weather, soil, and crop volume demanded a harvester that combined stability, power, and precision. By pairing track mobility with record-class harvesting technology, it gave operators a tool that could continue working when others could not. Number 5. Bourgault 3420 Paralink hoe drill with 71300 air cart. By the closing decades of the 20th century, farms across the Canadian prairies and the American plains were expanding to scales that earlier machinery could not keep pace with. Bourgault, a company from Saskatchewan, responded with designs that were bigger, stronger, and more precise. Their largest achievement was the Bourgault 3420 Paralink hoe drill, paired with the 71300 air cart, a combination that demonstrated how far seeding systems had advanced. The Paralink hoe drill stretched an incredible 100 feet when unfolded in the field. That span allowed farmers to cover more than 25 acres in just an hour under favorable conditions. What made this drill stand out, however, was not only its width, but also its ability to maintain even seed depth across uneven ground. Each opener was designed to move independently, following the soil's contours with accuracy. This ensured uniform germination across the entire width, a critical advantage in large fields where soil conditions could change quickly. Backing this wide drill was the massive Bourgault 71300 air cart. With capacity exceeding 1,300 bushels, it could run for long stretches before a refill was needed. The cart was divided into separate tanks, making it possible to meter seed and fertilizer at once. This saved valuable time during short planting windows and gave operators the flexibility to fine-tune input rates as they worked. In practice, the system reduced downtime while maximizing productivity, which was vital when weather conditions left little margin for delay. To move equipment of this size, extraordinary power was required. Tractors rated well above 500 horsepower were commonly paired with the Bourgault drill and cart. Engines with displacements greater than 15 liters, equal to 915 cubic inches, supplied the strength for such demanding work. Beside this, torque was also a powerful element. It often exceeded 2,000 pound-feet, ensuring the entire setup could advance steadily through heavy soils while pulling the enormous air cart fully loaded. Despite its wide field stance, Bourgault engineered folding systems so the drill could be narrowed for transport. Even then, the scale remained imposing and required careful handling to move between fields. Farmers accepted this compromise because once the machine was set to work, it provided efficiency that smaller drills could not match. Covering hundreds of acres in days rather than weeks reshaped expectations of what was possible during planting. The Bourgault system was not just about brute size. Its air delivery and metering technology ensured that seed and fertilizer were applied evenly across the full span. This balance of width and precision meant that the drill was as effective in ensuring crop consistency as it was in covering ground. The Bourgault 3420 Paralink hoe drill with the 71300 air cart remains one of the most ambitious seeding combinations ever placed in the field. By combining extreme width, enormous cart capacity, and precise seed placement, it provided farmers with a practical way to manage the challenges of large-scale planting. Number 4. Case IH Steiger 715 Quad-Track Tractor. When Case IH introduced the Steiger line decades ago, the idea was to give farmers machines capable of working the largest acreages with reliability and raw pulling power. Over time, the series grew in size and complexity, with each new generation setting higher benchmarks for what a modern tractor could do. The Steiger 715 Quad-Track emerged as the most powerful production model in the lineup, and it quickly gained attention as a tractor built to handle the toughest demands of today's broadacre farming. The first thing that made this machine stand out was its 4-track system. Instead of relying on wheels, the Quad-Track used independent rubber tracks on each corner. This design spread its considerable weight more evenly across the soil, reducing compaction and giving it the traction needed to pull implements of staggering width. For farmers working in soft ground or steep terrain, this system meant more consistent performance and the ability to plant, cultivate, or till in conditions where other large tractors might struggle. At the center of the Steiger 715 was a massive diesel engine built for endurance. Its displacement measured 15.9 liters, equal to 971 cubic inches. This block provided the steady foundation required for extended fieldwork, ensuring that the tractor could operate long days without faltering. Case IH engineered the cooling and fueling systems so that the power plant could sustain demanding loads under a wide range of conditions. The horsepower rating confirmed its scale, with the Steiger 715 producing 715 horsepower at rated output and even higher at peak. This allowed the tractor to operate implements measuring more than 100 feet wide, covering ground at a pace that smaller models could not match. For farms spanning thousands of acres, this ability translated into significant savings of both time and labor during critical planting and tillage windows. Torque was equally impressive, with the engine delivering close to 2,900 pound-feet. That figure ensured the tractor could maintain steady pulling strength even when facing deep soils, heavy equipment, or slopes. Operators noted that the torque curve provided smooth delivery, meaning the machine rarely bogged down under heavy strain. Instead, it powered ahead with the consistency that defined the quad-track design. Despite its size, the Steiger 715 was not limited to brute force. It featured an advanced hydraulic system with tremendous flow capacity, which allowed it to run multiple modern implements. With precision, the cab was designed for long hours, with suspension seating, improved visibility, and digital controls that gave operators detailed monitoring of performance in real time. Connectivity options meant the tractor could be linked into precision farming systems, ensuring that efficiency was not lost in the pursuit of power. On the road, the tractor could reach transport speeds of approximately 25 miles per hour, a practical figure for moving between distant fields. While fuel consumption was naturally high, efficiency was measured against acres covered, and here the Steiger 715 proved its worth by completing work faster than smaller alternatives. The Case IH Steiger 715 Quad-Track combined scale, traction, and technology into a package designed for modern large-scale agriculture. For farms that required both extreme strength and precision control, it represented a tool built to keep pace with the growing demands of today's fields. Number 3. Grimme Ventor 4150 Potato Harvester. Potato farming has always demanded machines that could move quickly, while still protecting a delicate crop. In the past, Farmers often relied on smaller units that required multiple passes, but as acreages grew larger, this approach became inefficient. Grimme responded by designing the Ventor 4150, a harvester that combined wide lifting capacity with careful crop handling. Its creation was not only about building something bigger, it was about meeting the dual challenge of speed and quality in modern potato production. The Ventor's most striking feature was its ability to lift 4 rows of potatoes in a single pass. For farms covering thousands of acres, this wide intake reduced harvest time dramatically. Equally important was the large bunker, capable of holding more than 33,000 pounds of potatoes before unloading. Operators could continue for long stretches without interruption, making it easier to take advantage of good weather during narrow seasonal windows. Powering the harvester was a diesel engine designed for long hours under heavy demand. Its displacement measured 16 liters, equal to 976 cubic inches. This engine gave the Ventor the durability needed to keep its multiple conveyors, separators, and cleaning webs running smoothly all day. The balance of strength and endurance was crucial for growers who depended on a single machine to complete the harvest on time. The horsepower rating reached 530 horsepower, which gave the harvester more than enough capacity to operate its large digging units and cleaning systems while maintaining forward motion. Even in heavy soils, where smaller machines often lost efficiency, the Ventor kept working at full output. This consistency made it valuable for operations where delays could cost both yield and quality. Torque figures also reinforced its reputation, with the engine producing more than 2,200 pound-feet. That low-end pulling strength ensured the harvester moved steadily, even when its bunker was full. Instead of slowing under weight, the machine kept advancing across the field, a feature that reduced downtime and allowed farmers to maintain steady progress. While capacity and power were impressive, Grimme also emphasized crop protection. The Ventor used an offset intake that distributed weight more evenly, preventing soil pressure from damaging tubers. Multiple cleaning stages removed soil and debris gently, keeping the potatoes intact for storage or market. Farmers valued this careful handling, since bruised crops often meant financial losses, and the Ventor proved that size could be matched with precision. Transport between fields was practical for a machine of such magnitude. The Ventor could reach road speeds of about 15 miles per hour, which allowed it to move efficiently without losing valuable time. Fuel consumption was high, but when measured against tons harvested per hour, the efficiency remained clear. The machine delivered output that far outweighed its operating costs. The Grimme Ventor 4150 stood out not only for its scale, but for the way it combined speed, strength, and gentle handling in one package. By uniting wide capacity with features that preserved crop quality, it gave potato farmers a tool that matched the growing demands of large-scale agriculture while keeping each harvest intact. Number 2, Agrifac Condor Endurance 2 Sprayer. In crop production, timely spraying can mean the difference between a healthy yield and significant losses. As farms expanded in size, traditional sprayers no longer kept pace with the speed or coverage required. Agrifac, a Dutch manufacturer with a long history of building specialized crop care machinery, answered that challenge with the Condor Endurance 2. Introduced as the flagship of their sprayer line, it was built to deliver capacity on a scale that matched modern agriculture, while maintaining the precision needed to protect both plants and soil. One of the defining traits of the Condor Endurance 2 was its reach. With boom widths extending to 180 feet, the sprayer could cover immense swaths of farmland in one pass. This reduced turning, increased efficiency, and allowed farmers to take full advantage of short spraying windows. Stabilizing technology kept the boom steady, ensuring even distribution across varied terrain. To power the system, Agrifac equipped the sprayer with a diesel engine, whose displacement measured 12.9 liters, equal to 790 cubic inches. This engine provided the steady foundation needed for long operational hours. During peak spraying periods, farmers valued the durability of the block, as it meant fewer interruptions when reliability mattered most. The machine produced about 500 horsepower, enough to carry its large boom, tank, and spraying systems without loss of momentum. This output allowed the Condor Endurance 2 to maintain speed in the field, ensuring that coverage remained consistent even under heavy workloads. For large acre operations, this capability translated directly into timely completion of tasks. Torque production was equally notable, with the engine delivering close to 2,000 pound-feet. This ensured the sprayer advanced smoothly, even when operating on softer soils, or while carrying full loads. Farmers could depend on it to remain steady in conditions that might hinder smaller sprayers. Capacity was another area where the Condor Endurance 2 distinguished itself. The tank carried more than 2,100 gallons, reducing the number of stops for refilling. Combined with a high-flow pumping system and intelligent nozzle control, the sprayer offered accurate application rates and minimized waste. The ability to apply both efficiently and precisely gave it an edge in modern crop protection. When moving between fields, the sprayer could reach road speeds near 30 miles per hour. While fuel consumption was naturally high for a machine of its size, efficiency was measured by acres sprayed per hour. And here the Condor Endurance 2 consistently justified its presence. The Agrifac Condor Endurance 2 proved that size and precision could be combined effectively. With its wide boom, large tank, and advanced control systems, it gave farmers a machine capable of managing crop care across vast acreages while maintaining accuracy. Number 1. Krone Big X 1180 Forage Harvester. Forage harvesters have steadily increased in size as livestock operations demanded more silage each season. Krone, already a respected builder of agricultural machinery, set out to create a harvester that would raise the standard of output. Their answer was the Krone Big X 1180, a machine that combined massive size with advanced features designed to work at a pace earlier harvesters could not match. The physical scale of the Big X 1180 was immediately clear in the field. Its pickup measured nearly 3 meters, or about 9.8 feet, wide enough to gather large amounts of crop in a single pass. Fewer passes meant faster work and less soil compaction, a benefit that operators noticed quickly. Fully equipped, the harvester weighed more than 37,600 pounds, giving it the stability needed to process thick forage without hesitation. At the heart of the machine was a Liebherr 12-cylinder diesel engine. Its displacement measured 24.24 liters, equal to 1,485 cubic inches. This block was designed for heavy workloads, with advanced cooling and fueling systems that allowed it to run for long hours in demanding conditions. Farmers valued the durability, since a breakdown during a short harvest window could prove costly. Horsepower figures confirmed its place among the most powerful harvesters. Output exceeded 1,146 horsepower, giving the machine the ability to run wide chopping drums and conveyors at consistent speeds. In dense maize or wet silage, where smaller machines often slowed, the Big X 1180 maintained steady performance. This reliability kept the harvest on schedule when timing mattered most. Torque was equally important, with the engine producing more than 3,000 pound-feet. This gave the harvester the strength to keep its chopping and feeding systems running smoothly under full bunker loads. Instead of straining, it pressed on with consistency, ensuring that output remained high even in the heaviest conditions. Transport speed added to its practicality. The Big X 1180 could travel at nearly 25 miles per hour on the road, which meant quicker movement between distant fields. Though its size made it imposing during transport, this ability saved valuable time across large acre operations. Fuel use was significant, but efficiency was measured in harvested tons per hour, and here the machine performed exceptionally well. The cab was designed to support long working days. Large windows provided clear views of the pickup and chopping unit, while controls were arranged for intuitive operation. Monitoring systems supplied real-time data on throughput and feed quality, allowing operators to make quick adjustments as needed. With its broad intake, immense torque, and refined design, the Krone Big X 1180 became a machine that matched the demands of the largest farms and set new standards for efficiency and silage production. The scale of these machines proves that modern farming is as much about engineering as it is about soil. Have a favorite among these giants? Tell us in the comments. Hit like if you learned something new, and subscribe for more.